webinar in our new platform. It feels exciting to change from another to this one. So about this webinar will be recorded. We have Q&A. You can post your questions in the Q&A settings. Please be aware that we only handle the questions. No statements will be handled. We also limited the Q&A to 5 minutes or 5 questions. Participants will receive afterwards the link inclusive the available presentations. So you can have a review afterwards. View findings and publications of this webinar do not necessarily represent the view or policies of the AVERE or its individual participants. So the speakers that are joining today will speak on behalf of their own views or findings. That brings me automatically to our first speaker. Nils, very welcome today. Nils Rosmuller is a professor at the Energy and Transport Safety Instituut of Fysieke Veiligheid from the Netherlands. Nils, welcome. I miss Nils on the front, so I'm still waiting for his presence. For some reason, he is not there yet. Nils, are you there?
Yes, I'm there. Yes. Thank you.
Sorry. Thank you. Be my guest. You can take over. The floor is yours.
All right. Thank you very much. My first question to the crew is whether or not my slides are visible for you. And when I see a yes, then I continue with my presentations. And also when you confirm that you can hear me. So, Philip, can you hear me and do you see my slides?
I have no idea.
So, once again, can you hear me and see my slides? I can see my slide, but I don't know whether the audience can see it and hear me. So please give me a confirmation that both are arranged. Still the same question to the crew. Are my slides on the screen and is the audience able to hear me? It seems as I am the only one who can hear myself and see my guy. Hi, Philip, I can see you. Can you hear me and do you see my slides?
I do see your slide. I'm sorry, I was completely blocked for some reason. I will go offline now and
Yes, but still I need a confirmation that everyone can hear me and see my slides. Still the same question to the crew. Am I live? Can people hear me and can people see my slides?
We did see your slides and you're completely live. So please go ahead with your presentation. Thank you.
All right. Great to be here in this audience with guys who are very familiar with battery electric vehicles. And for me, as a guy dealing with safety, we are very interested in the safety aspects of battery electric vehicles, and in particular in confined spaces like, for example, a parking garage. And my name is Nils Rosmuller. I'm an applied professor at our Dutch Institute for Fire Safety and Disaster Abatement. And we conducted a literature study after the fire safety aspects of battery electric vehicles in parking garages, and we suggested some safety measures how to deal with these typical fire safety risks. And that's what my presentation, the couple of 50 minutes, will be about. I'm going to show you the next slide, which is this picture of a parking garage at the Delft University of Technology. And what you see here is that the municipality, they pose some additional requirements regarding to the uses of this garage, namely electric and hydrogen vehicles are forbidden, which is not the message that I will pose the couple of minutes. The message that I want to bring to you is these typical new kind of vehicles, new between brackets, they pose certain typical risks. And what we as the Institute for Fire Safety are emphasizing is that those kind of typical risks ask for certain, let's say, new kind of recommendations and safety measures. And I will give a short introduction in the safety measures that we defined and which can be used. I said, don't say must, but can be used to deal with those safety risks. So first of all, I will introduce to you why we conducted our literature study. Then I will touch upon the specific safety risk and uncertainties that go along with BEVs, battery electric vehicles. And I will, let's say, compare them to the internal congestion engine vehicle, so the ICE. And so we can see what is now typical for the battery electric vehicles regarding to fire safety. Then I will touch upon some safety measures from the construction side, from the organization, from the installation, and also from the fire suppression. And then then I'm ready with my presentation, and I give the floor to Philip again. So first of all, a little sort of context. In the Netherlands, we have 25 safety regions, which is a sort of entity from the public authorities, and they have three tasks or roles. First of all, they are the safety advisor for the municipalities, for the authorities, for example, in processes regarding granting permits for parking garages. Second of all, which is a very clear task and which we know them all about, is to, for example, suppress fire. So they are the emergency responders. And finally, they are also advisors, for example, for people and organizations who develop activities and buildings, and so they can go to the safety regions and ask for advice. So they have three main roles, the safety regions, and we as a Dutch institute, we try to provide them with knowledge and education and let's say tips, do's and don'ts, how to deal with their operational tasks. That's, I think, enough for the safety regions. Let's go to the electric vehicles. These are some numbers from the Dutch number of registered BEVs in the Netherlands. And what we see, let's go to the bottom line, that the total number of BEVs is increasing to high numbers in a very, let's say, steep mode. For example, at the end of 2016, we had 112,000 BEVs, and 3.5 years later, this number doubled. So the increase is pretty steep, and let's say in a couple of years from now, we are aiming for more than 1 million BEVs in on our roads in the Netherlands. So this increase is huge. And when you have a lot of battery electric vehicles, then you need to charge them. And likewise, the vehicles, there's also a big increase in the number of charging points, which is pointed out by in particular the lower line in this graph, where you can see that at the end of 2019, we have about 200,000 charging points in the Netherlands, which are both public and private and semi-public. So these are the numbers regarding the battery electric vehicles and the charging point. But what is going on in society? Let's say, first of all, the law, both from the European Union and the Dutch national law, we have an obligation to have charging point in parking garages. Of course, it is to stimulate this, let's say, this more climate-friendly use of energy in our mobility system. And the first is that each new parking garage in the Netherlands have the obligation to realize at least one charging point in the garage. And for the existing garage, is it at least 1 point starting from January 2025. So our policy is to stimulate electric mobility and to realize the more electrified mobility. We have the obligation to realize charging point in our garages. Another societal development is that we see some fires with battery electric vehicles. I put some fires on the screen. We have some fires on the road, on our highways, but also in showrooms from car manufacturers, also during charging activities, and finally also in parking garage. I put two parking garage fires there, Alkmaar and Ede, which are two cities in the Netherlands. And first of all, I have to say that the electric car was not the cause of the fire. In both cases, this was arsoning, and electric cars were involved in the fire, but were not the accident cause. The point here is with this slide is that for now, we do not have codes or regulations for fire safety in parking garage related to these battery electric vehicles. And one could ask oneself, is this a problem? More or less it is, because we see some typical risks that go along with charging and parking electric cars, and we think it's wise to think of those risks and see what kind of safety measures one could take to prevent for big fires. But first of all, the system itself, probably well known for you, the lithium ion, the Li-ion batteries, they are packed in a battery module. So the cells are compressed in a battery pack. The battery pack is part of the car. The car is being charged in the garage, and the garage is the confined space where, in some cases, a fire could take place. And in particular, this combination from the electric car in this confined space makes it a harsh environment for the firefighters to act. So what we see is there are some specific safety risks and uncertainties that go along with the battery electric vehicles. And I will touch upon each of these safety risks and uncertainties in my next slides. I will touch upon the fire causes, the heat release, the firepower, the fire dynamics, and the combustion products. And each time for us, it was relevant to see what does it mean for risk prevention or risk control or risk management. And finally, also, what would that mean for the fire suppression tasks? We got our knowledge from a pretty exhaustive literature study. And what we did is also in this study, we compared them to the ICEs. And I go with very less detail, but big steps upon each of the topics. The fire causes. We see some additional and new fire causes in literature. And that's, let's say, more or less logical, because the traditional fire causes of a fossil car getting fire, now you could have, let's say, failures in the production of the battery packs. The charging could be a cause of fire, but also, for example, small accidents on the road, which might have give a shock to the battery pack, which could, from literature point of view, could be some specific fire causes compared to the ICE cars. Looking at the heat release, literature shows that the heat release is comparable between the BEVs and the ICEs. And in let's say in centigrade Celsius, it's about 800, 900 degrees Celsius, which is the heat release from a car fire, whether or not it's electrical or let's say a fossil fueled car. So there's no much difference between the two types of cars. Let's see the power of the fire. The fire power is more or less comparable between the ICEs and the BEVs. It's about 8 megawatts. And what we see here is that, in particular, the mobility of cars and the more rubbers and plastics that are being used in the cars make that the power of the fire, the intensity of the fires increases more and more the couple of, let's say, decennia. The fire dynamics, which is an interesting point, we see a slower development. So when you have the ICE cars, which pretty develop in a pretty fast mode, you see these battery electric cars, they develop in a slower way, but they last longer. And the point here is that in certain ways they keep themselves in a sort of self-developing fire. We call it a thermal runaway, which might last for 12 to 24 hours and sometimes even a couple of days, which make it a pretty difficult way to deal with it from a firefighter perspective, because to suppress the thermal runaway, it needs a lot of water, and you are trying to cool the battery, but it's pretty difficult to put the water on the battery cells because of the battery pack that is a very well developed part of the car that keeps all the external influence outside the battery cells. So you don't get the water on the battery cells themselves. So that's why it takes very much water to cool the battery pack. In fact, to cool the battery cells. And finally, when you have a fire, we looked at the combustion products, and what we see from literature is that in particular, the hydrogen fluoride, the concentration is a bit higher for the BEVs than compared to the ICEs. So what we conclude from these kind of sources that we studied is, from a safety point of view, for people trying to escape from the parking garage, there's no much of a difference between a battery electric vehicle or an ICE vehicle. But from a fire suppression point of view, there are some typical, let's say, problems of issue which make it very difficult for the firefighters to to operate or in the garage itself because of the confined space, the long logistics they have to overcome, the big spaces they have to act in, and let's say the thermal runaway issue that needs a lot of water to suppress or to contain the fire. And therefore, we thought of what kind of measures to control the risk could we think of to deal with those risks. And we looked at measures dealing with the construction, installations, some organizational methods, and in the end also measures that could be facilitate the fire suppression. And I will not touch upon all the measures that we formulated in our report, which is downloadable from our site. It is in Dutch, so that might be a problem for people who are not able to understand Dutch, but maybe Google Translate will help. There is a management summary in English. The fire safety measures, they had all kind of a variety. For example, for the construction, we looked at cladding, local. For example, at those places where electric vehicles are parked or charged, what we could do is to make the construction in heavier, so they can resist higher temperature for a longer period. Or, for example, you could think of develop a tub where the car could be let's say drowned. So there's a lot of water to cool the fire in the battery pack. From an installation point of view, we thought of the sprinkler and the water mist systems, but also emergency shutdown buttons, collision protection of the charging points, and also terms of use for people parking into the garage. For example, when you have had a small collision, but you don't see any damage, it could be that still there is a sort of hidden damage in the battery pack. So, for example, we could touch upon ways to behave as an electric car driver, when to park your car, or when to go, for example, to a garage to go to the maintenance instead of parking your car below houses or something like that. And finally, we have some measures from an organizational point of view. First of all, we think right at this moment it's wise to park and charge your cars as close as possible to the entries and the exits on street level, because then it facilitates let's say the firefighters and the guys from the road authorities to pull the car out of the garage or to suppress the fire, but also to educate the car users how to deal and how to maintain and how to behave in a safe way when you have your electric car and park it into the garages. And then the next step in our report is what are all these kind of measures, are they available and proportional for all kind of types of garage? No, they aren't, but at this moment we are not able to specify which type of measures should be applied in which type of garage. But there is a big variety of garage. I put some pictures over here. And what we suggest is that when you intend to have charging points and electric cars in your garage, which was not originally foreseen in the building and the construction of the garage, go into contact with the fire safety advisors and think of what kind of measures would be would facilitate the fire safety. The safety measures that we formulated is not a sort of long list that you have to realize in practice. So there's no accumulation of all these safety measures. We think try to get the conversation going on and what kind of safety measures should work in this typical garage that is the object which you talk about. And finally, also, it's no one size fits all. It's really, let's say, customization of your safety measures regarding your type of garage and the usage of your garage. And in the end, we also try to look at what are the probabilities. We don't have a very, let's say, well view on the probabilities of the accident causes. What we see is that there are some typical effects that go along with battery electric vehicles, and that's for the firefighters. Is that the way of how they look at this issue? So they have a harsh environment, a confined space, a parking garage, where the fire suppression is, let's say, complicated, nasty, and therefore we suggest some safety measures to customize your garage to deal with those typical safety issues regarding battery electric vehicles. And then I come to, let's say, my final slide. If you have any questions, please post them, or if you come with questions later on, we have an email address where you can post your questions. So that's, I think for me now, it's enough.
Thank you, Nils. Thank you to share your insights on this intriguing topic, let's say it like that. So far, we didn't receive any questions in the Q&A. If people still have questions, I will let them know. As well, we still give the availability also to share questions by private email, so they can filter it by us. So that brings me immediately to our next speaker, Henk. You have a different point of view, or complementary. We don't gonna say different. Complementary point of view. You're representing the Dutch organization DOET. Please introduce yourself.
I don't know if I've been here now, but I think.
Yeah, we hear you.
Yeah. Okay. Well,
thank you.
I will put on the camera as well so people can see me. I'm Henk Meiborg. I'm in this case working for the Dutch Organization for Electrical Transfer. Safety in the sense of battery safety is a specialty in this field. We had a lot of discussions already in the past, also with Nils. So this presentation is not totally new, but I sense some changes. So I think the discussion already being made in Holland is good and is showing effect. I want to start actually with a funny question, just to turn on our brains. Are petrol and diesel cars in the car park more flammable than the electric car, or more dangerous, whatever you want to read? This is a big discussion in Holland. It's currently taking place, like I already said. Of course, Holland is after Norway, which we will be heard from later on from Ståle. A big issue because in Holland we have already a lot of cars on the roads. In Niels's presentation, we saw the numbers. So I won't go into that, but there are some issues which we need to discuss. Charging would be one of the greatest risks, is stated, but also the fire behavior and the substance released would cause major problems, and you have to think in gases and so releasing when a car is on fire. Reporting on battery fires in the Netherlands. Yes.
Henk, can I just interrupt you?
Yeah.
We hear some sound issues. Maybe you can shut off your camera anyway to gain some bandwidth.
Yeah, I can do that.
Okay. And hopefully it will be better done. Thank you.
It will be better. I can also maybe wire up my microphone instead of using the hands-free one. Can you hear me now?
Yeah, definitely.
Okay, I will continue with my headphone on. That's maybe a little bit better. Reporting on battery fires filled a lot of debates in the media. We had some television shows who told that everybody will be going to die if we continue to charge electrical cars in car parks. And therefore, there is a lot of discussion, and this is led to the fire brigades in Netherlands having some statements also in the media. And our criticism is that they are mainly based on lithium batteries in general and not specifically for electrical cars. And as a result of that, at the moment, there is a stagnation in the rollout of charging infrastructure, which means that due time, this will lead to a stagnation in rollout of e-mobility in total. We don't want that. That's also stated by Nils, that it's not the way of dealing with new technologies which are necessary to face our energy transitions problem. I want to state a little bit about the risks of fire when charging, because of the fact that the fire brigades in Holland stated that overload to deeply discharge, wrong charging, wrong use of chargers, and overheating could cause this thermal runaway already mentioned by Nils. And this is a problem in this sense that this is for normal lithium-ion batteries the case, but not especially for electrical cars. We can charge in many ways lithium-ion batteries, and we have had some modes to relate to the different possibilities. And mode 1 is what we all do with our telephones and laptops. Mode 2 is a little bit more controlled by the so-known granny chargers. They have a box in between the cable and the both plugs, which can put off the charging session when something is wrong in the car. But it doesn't help when something is wrong in the infrastructure from socket to net connection, grid connection, for instance. And then we know mode 3, and this charging mode is controlling the same as in mode 2, but because of the infrastructure which has to be new to install mode 3, it's a lot more safe, because then we have our regulations which have to meet to install this. And then we have mode 4, which is more or less the same in sense of communication between the battery and the charging stations, and it's then in the DC field. At mode 2, 3, and 4, only in mode 2 and 3, we use the onboard charger in the car. So one of the reasons on my slide before, where the fire brigade stated that changing a charger or using accidentally a wrong charger is not an issue, because the onboard charger provides us from making this mistake. And that's the case by mode 2 and mode 3. At mode 4, we charge with DC. So there the charger is standing next to the car, but these chargers are in sense of communication all the same and related to the standards which are agreed on in the car manufacturing industry. So we say, as organization DOET, we won't charge cars with mode 1 and mode 2, because mode 2 like I already mentioned, between the socket in the wall and the grid connection. We have no control of what's lying there. That could be a cable 50 years old, too small, and could be heated up. But mode 3 and mode 4 shouldn't be a problem because new infrastructure is always the case in that. So with the choice for mode 3 and mode 4, the reasons given by the Dutch fire brigade are no longer applicable in the event of a fire. It couldn't cause a fire at that stage. And this is, I'm sorry, there we were. This is important because this changes a lot in sense of the measures in sense of organization Nils just put out. I'll come back to that later on. It also, a lot of these possibilities the Dutch fire brigade states aren't applicable because of the fact that the battery management system in the car is shutting off the charging process or shutting off the car, for instance, when the battery package is damaged too heavily, and then the car can't run anymore. So the battery management system is also playing a big part in this stage. Then, of course, when there is a fire, Nils mentioned already that in the parking garages, 2 times ascending was in place. Cars were put on fire by somebody who had a lot of fun of that. But it wasn't a reason which was related to the fact that it was a battery electrical vehicle. But if they are on fire, of course, then we have to deal with some problems, and it can be fire suppression, already mentioned by Nils. We have some other releases from the fire, which are maybe a little bit different than by ICE cars. We have a pollution risk of the water, which is necessary to put out the fire, and so on and so on. And several studies have been done. We listed up all these studies, and you can use the link in the presentation, which is able to download afterwards, to all these studies. And most of the studies are used by Nils as well for their vision on this issue. I already mentioned that fire suppression is difficult. Nils has mentioned that as well. And actually, one of the main questions I have for Nils is, what does a fire brigade do when there is a fire in a parking place like in Alkmaar last month or in Oslo last year? Because in my opinion, the fire brigades control the fire, but waiting until all products which are able to feed the fire with energy are used up. So in that sense, it shouldn't be a big of difference. Nils already mentioned that 8 megawatts was the number of the fire heat release which was available in a car, and that it isn't much difference between an electric car and a BEV. But we made some calculations as well in sense of how much energy is in a car available, and we see not much of a difference there as well. So that's still a question, and we hope with the findings from Nils out of the fire in Alkmaar, which was recently, so there are no further information yet available of this fire, but we hope to learn a lot of that due this research. Then the Dutch fire brigades are stating that in the future this problem will be bigger and bigger and bigger because of
all kinds of developments in the market of electrical cars. And one of the things I wanted to mention, there are more things we don't agree on, but one of the things I want to mention is that the fire brigades in Holland stated that the battery packs in cars will grow above the 100 kilowatt hours. And actually last week Opel announced that 33% of all the new Opel Corsas, a B-class model with a 50 kilowatt battery, is being ordered as an electrical car. So you see in the market that there is more demand for smaller cars with smaller batteries. A lot of new cars have also much better energy efficiency. So the tendency is to use smaller batteries that we can charge faster. And even Tesla is going this direction. And in the picture you see, and I've made this picture also a little bit bigger to let you see this a little bit better, that with 250 kilowatts, we can charge more than 1,600 kilometers per hour. And these are the charging rates which are able to use now with, for instance, a Tesla Model 3. This car is running on 400 volts. There are also developments for 800 volts where we can use double the capacity, because the batteries can have more power and the cables can have more power with the same amperage. So in the near future, we will see more and more pictures like this, where a charging station is part of a gasoline station and where the cars aren't longer than 15 minutes. So the development in the future is more or less smaller batteries which we can charge faster. Then back to the question I started with: are petrol or diesel cars in a car park more flammable or more dangerous than electrical cars? We think it doesn't make that much difference if there is a battery electrical car or a petrol car. And one of the reasons is, of course, in 50 years, a Mini developed from the very small car at Car Place number 17 to actually a very big car at the Car Place parked on Car Park Place 18. And this causes a lot of problems as well for the fire brigades. But these problems are never mentioned that loud as now mentioned that the BEVs are a problem. So, like I said, I have still some questions for Nils in sense of how we can overcome this different point of views. And it would be very nice to discuss this at the end of the presentation from Ole maybe, or after my presentation. Thanks for your attention. If you have any questions or you want further information, then please contact us at this information.
Thank you, Henk, for your contribution of today, with sharing your nice insights. I got a question here in the post. Maybe we can share the question to you and Nils as well. So when the fire is in the parking garage, how often does the fire brigade choose to let the fire die out in a controlled way? Or is it not true that the fire in the garage is always a difficult place to distinguish a fire?
Well, that's the same question I have for Nils, so I would like to have Nils to give his opinion about that.
Ståle, you're also welcome to contribute on the question if you have insights from your point of view.
Yes, not exactly sure how much time, but in some cases a lot of time, that's for sure.
Any other person wants to answer something on this? I see that it has been already answered. Written.
What's the question? How often do firefighters or fire brigades
choose to let the fire die out in a controlled way? When did they make the estimation to do it controlled, or when did they really go for it to distinguish?
The standard operating procedure in the Netherlands is becoming we do not enter these kind of confined spaces with these risks. However, the practice will be that the fire chief at the entrance of the garage, he is the one who makes a decision. And the point here is that from a general point of view, we are not promoting to enter the garage because we are not able to get a clear view on the risk in a generic way. So what we propose is to take safety measures to prevent the safety risk instead of letting the firemen or women at the entrance of the garage take these kind of life-threatening decisions. So that's the generic way. But the point here is, in each garage fire, at the end, the firefighters will enter the garage. And the point is, when is this decision being made by the fire chief, and which kind of arguments will he use to enter the garage? And that's where we have the standard operating procedure from. You don't know the risk. You are in a harsh environment, in a confined space.
So, of course, when you get confronted by a fire in a parking lot, and you go as a fire department towards this fire, in the first place, you will never know what kind of vehicle it will be. Yep. So, if you cannot approach the vehicle, it's the question: will be it an internal combustion engine or will it a battery electric vehicle? So it's handling the fire needs different approaches, but when you arrive in the first place, you don't know it.
I talked a little bit about the future, and I said that the batteries are getting smaller instead of bigger, but also we can say something about the steep slope, which is telling us how fast new cars sold will be all electric in the future. And if we see that at the moment, this year, 7% of all new sales is battery electric, and that's doubled in comparison to last year. And if we compare it with the year before, it's doubled also. Then if it is going to double every year, then in 2025, all new cars will be electric, or at least have a battery. So in my opinion, the fire brigades should, as of now, always state that there is a battery electrical vehicle in the car place, in the car park anyhow.
This is of course, we have the upcoming electric vehicles. We are not confronted really with fuel cells. So also can ask questions, is there more risk on biofuels? Is there a different reaction on fire with E85, ethanol, the flex fuel vehicles? Why is there so much focus on battery electric vehicles?
Well, that's mainly what I tried to ask with my funny picture, which shows the Mini of 1970 and the Mini of 2020. The normal internal combustion car had a big development. It used to be a chassis of steel with all kind of steel elements, and the only rubber or plastic which was in the car was the chair and the wheels. And nowadays, when a normal IC car is getting on fire, you can't recognize the model anymore because it's all plastic. So the development in sense of cars in general that's fast developed in the last 20 years, that you should ask yourself the question, isn't it dangerous at the moment anyhow to park a car in a parking garage? And the discussion in Holland, based on what's happened in media, is that there is a big problem because we are going to drive electrical cars. But if you take in account that the last 20 years every car is more than twice as heavy and it's more plastic than steel, then that shouldn't be the question and shouldn't be the discussion. And that's mainly where we as an organization are trying to fight against, because it puts it in a bad daylight. A lot of owners of parking garages are now saying we don't install charging infrastructure at the moment because we don't know what's happening.
Yeah. So
they shouldn't build a parking place then. If they are so, if they have this problem with safety, then they shouldn't build a parking garage.
No. Nils, I see you were confirming the statement of Henk. So what's your point of view on, we focus so much on BEVs. There is indeed a lot of change in technologies on the internal combustion engine or the classical petrol car. We see hybrid versions, we see plug-in hybrids, we see biofuels. Hydrogen is not that popular yet.
No, not yet, but probably in 10 to 15 years from now, we see more hydrogen cars. But the first thing is, and Henk is clear, the cars have been changed a lot. The amount of rubbers and plastic has increased to enormous extent, which makes the fire load and the temperatures completely different from the fire codes where they have been developed for the parking garage. So the fire curves that we used for our fire codes are let's say prehistoric compared to the cars that we now have. So that's point one. So absolutely right what Henk is telling. Then the second point is now that we use the parking garages also for another type of activity, which is charging. First of all, we use the parking garage for parking, and now we use it for parking and charging. I do not say that charging is the activity which causes the main problems, but it's an additional activity, and we have a new type of energy stored and phenomenon when a BEV gets fire. So it's an accumulation, at least in the Netherlands, it's an accumulation of the cars that have been changed over the 20 to 30 years, more rubbers, more plastics. We have new kind of energy storage in the cars, and we have a new activity in the parking garage, which is charging. And this accumulates to this more and more, emphasis on the safety of parking garage, because firefighters have, on the other way, made a sort of, we do not enter every space anymore to, let's say, suppress fires. We from the firefighters, we say, think of the risk in front at first before you say, the guy from the fire brigade, they will handle the fire. Now we have another point of view. We say, we know these risks. What can we do to control them? What kind of measures are proportionally? And in the end, is there any type of activity that the fire brigade could do to suppress the fire? So that is, I think, the historic perspective on the development. Why right at this moment the fire garage codes are, in my words, prehistoric in the Netherlands compared to the development of the car fleet, and why it's absolutely necessary to think of measures to deal in a proper way with the fire safety risk in these garages. Are you still there? Or?
Yeah.
Philip, it's gone.
I think, Nils, I think you're absolutely correct. I'm sitting here thinking about the actual car fleet in Norway. We have roughly 300,000 battery electric vehicles running in Norway. And I've been studying the statistics for quite a few years. And when Mode 3 equipment is used for charging, I don't know any incidents where a fire started due to charging. We've had a few incidents with Mode 2 charging and the Schuko sockets when you had some meltdowns of sockets and some cables. But when you think of just how many BEVs we have in Norway, the number of incidents is low. So I think the key here is to bring the message across like you just did. Make sure the equipment for charging is good, and when used properly, I think the risk is it's little, and then again you have a low risk when charging using the correct equipment. And you have a small risk for mechanical damage to the battery pack, but I think it's all in all, it's a fairly low risk concerning this. I think Norway goes to show that this is the case so far. Also, when studying the fire statistics for a few years back.
Okay, Ståle, let's go to your presentation. Share your insights and your experience that we have of Norway. The EV country of the world, the highest penetration of electric vehicles that we can imagine today. So go ahead.
Yeah, thank you, Philip.
I have to go. Excuses for my.
No problem. Thank you for your contribution anyway.
See you.
Bye-bye.
Bye, Niels.
Bye-bye.
Bye, Henk. Bye, Niels. Sorry.
Yes, I'm going to go through some details about a parking garage fire that occurred in Norway, in Stavanger Airport, Sola, in January. It all started when a BEV wrongfully was blamed for this massive fire. And of course, as an employee with the Norwegian EV Association, the world's largest EV owners association, and to me, this is a passionate cause, actually countering prejudice and misconceptions around the relative fire safety of BEVs. So once again, we had to go to work to establish what we believe is the correct answer to the questions. And what we realized quite early on is that we had this massive fire in the afternoon on January 7th, and quite fast we had media stories about that the fire starter was a battery electric vehicle. And even though this information was unconfirmed, we had this media frenzy. And as mentioned, like we always do, we quickly assumed a close examination to find out what was the actual facts of the story. More than 1,600 cars were parked in the parking garage complex, comprising 3 different buildings built at different times. And all those cars have had to be removed since, and the parking complex is about to be torn down as we speak, 8 months later. And we also had a fresh RISE fire research report pointing out several mistakes were done in advance. And as some of you may know, that RISE is a Swedish company with a Norwegian subsidiary, partly owned by Sintef. So they did this report, which I'm referring to quite a lot during my presentation. So how many BEVs in Norway and in the county where this fire occurred? As you may know, more than 50% of all new cars sold in Norway are BEV. And of the total fleet, you have a little more than 1 out of 10 on the roads, and a little bit more in Rogaland County. So that means an equivalent BEV share might have been in this parking garage at the time of the fire, even though the number is still not confirmed. As it turned out, the witness claims to the police were wrong. The fire starter was in fact a 15-year-old Opel Zafira with an internal combustion engine. And it caught fire when a family returned home from a trip abroad, and they were about to travel to their home, and this whole thing started. And even though the diesel car was to blame, the public damage was to a large extent done, meaning we had to go to work. And as you can see, German Facebook post on this page sharing a Norwegian article with this BEV fire angle. So this we actually had the day after the fire. We had the Norwegian Broadcasting Corporation interviewed the local fire chief who was in charge at the airport, and you can you may not understand Norwegian, but you can see the text.
Brannen startet i en dieselbil. Mange diskuterte hva risikoen med elbiler som flere nå har kjøpt.
Ja, det har jeg registrert på nettet at det har vært stor diskusjon om. Her det brent flere elbiler uten at det har vært noen store utfordringer for oss i brann- og redningstjenesten. Og det tror jeg skyldes at batteripakkene ikke har tatt fyr. De ligger i bunnen av bilen og har ligget i trygge omgivelser, mens bilen eller det som over av seter og så videre, det har brent opp.
Yeah. So this guy, Mr. Nils Erik Hågenrud, actually helped tell the story about BEVs not being that dangerous, and we had more information coming out in the upcoming days. But we also had the local police admitting that they shared this early witness claim suggesting the fire hotbed was a BEV, and we believe this may be partly down to the fact that battery electric cars in Norway is a hot topic, and of course in the media as well. So I guess that's why the media wasted no time publishing stories using this unconfirmed information, and we had a lot of misleading focus. So like I mentioned, we went to work to get this straight, even though we didn't know at the time when we started if this was an ICE, a car with an internal combustion engine, or a battery electric vehicle. So we wanted the facts, and well, we didn't know what to expect. This was the first story in one of the online news services saying that flights have been stopped and 300 cars destroyed after a massive BEV fire, even though they didn't know. We also had this news story travel abroad. You can see the story from Bloomberg at the bottom. You can see another allegation about the electric car before this was confirmed. We also had a lot of local newspaper stories in Norway. And you might know that battery electric car in Norway is called elbil. And that's what the red rings here is all about. Fearing BEV fires underground. This fast, the EV might catch fire. BEVs might mean trouble, and not prepared for fire in BEVs. Well, different opinions. We also had an insurance company that took the opportunity to actually name BEVs fire bombs, while the media apparently seemed to be out there to save the original hypothesis, focusing on BEVs only. I don't remember seeing any story telling any, giving new information on the relative risk of driving a car with an internal combustion engine. So retraction of original truth that the car was a BEV was really slow. And this insurance company, they actually stated that this is something we have feared for a long time. And we went straight out in the media to counter this. And, they had to, I don't think they were too comfortable when it turned out to be an ICE car, and they went silent after a while. But we felt this was taking such an opportunity to spread fear, uncertainty, and doubt without any confirmed information was not a very nice thing to do. Because as the local the Nordland Fire and Rescue Service, they concluded quite clearly that BEVs did not affect the fire development in a different way than ICE cars. So there you have it. So then again, you had in any of course, we welcome any research in this field, and any research of this scope with this size, so many cars, is of course impossible. So we had this unique opportunity to delve into this, partly due to the scope and also due to the media focus, and because we believe that quite a few cars would be battery electric inside the parking garage, and higher than any number anywhere else in the world. So I'm not going to dig too deep into this, but according to this mentioned report from RISE, the garage was in no way dimensioned to withstand a massive fire. Only 10 minutes, sectioning, installation of fire alarm, and a total lack of extinguishing systems, and the fire resistance of the load-bearing structure and fire risk have not been fully mapped and assessed. So dedicated extinguishing systems like sprinkler and water mist, like mentioned earlier during this webinar, would probably have reduced the potential for fire spreading to other cars, and also making it easier for fire and rescue crew to strike the fire down before it became so big. And you had a similar case also in Liverpool, UK, back in 2017, where a similar amount of cars were inside. So, as this story turns out, when the new parking garage is built in the Stavanger airport, it is going to get sprinkler, because the old one didn't have. And also, the research shows there is no significant difference in fire intensity or duration, regardless of different involved drivetrains. And also no thermal runaway seems to have occurred in any of the parked BEVs. And also we don't know for sure at the moment if any of the battery packs were totally damaged by the fire. But it seems, or is undisputed, that the contribution was limited or none. And also adding to this is that when water analyses were conducted afterwards for selected metals that are in batteries, they didn't show any lithium and only low concentrations of cobalt. So this means that the water used for extinguishing the fire didn't contain any of this, or almost none of this. And this leads to the conclusion that the BEVs did not contribute to the fire development beyond what is expected from conventional vehicles. And I think that's an interesting finding, because people believe a lot of things, but getting some new knowledge doesn't hurt. I'm not going to dig too much into the charging, as charging was not a big, not a very important subject concerning this garage. Not a lot of charging points, and probably a lot of the BEVs parked in the garage were not plugged or just standing parked just like any car. But as I mentioned from experience in Norway, fire statistics indicate that when using proper charging equipment, mode 3 type 2, there's a very small probability for fire or also ignition or consequence of the fire. So we recommend as an association that our members use mode 3 type 2 charging equipment for sleeping well at night and feeling reassured that car charging is safe. And also we, during my rundown of this research, there are quite a few paradoxes in this matter. Just like Rise Fire Research summarizes, and I quote, "The difference between the impression of BEV involvement in the fire from the media and the local fire and rescue service observations is in itself an interesting result from the incident." I think that's something to think about, because a lot of opinions, a lot of different messages spread through social media, and well, I think we can say we had quite a fire in social media as well in the days following. So, running towards the end of my presentation, we feel that the further technical studies of fire damaged batteries from both BEVs, HEVs, PHEVs is necessary. And we also, as an association, cooperate actively with national authorities like Directorate for Civil Protection and Emergency, in short DSB. We think it's extremely important that national authorities take this coordinating role, making sure we can counter misconceptions with facts and learning. So, getting to the lessons learned from this actual happening. The misconceptions, they are quite hard to strike down. They spread so much easier in the media than you actually get to kill them off. And we are absolutely sure that it's key to have a knowledge-based focus on incidents like this. And because even though it's know it for sure, it's probable that similar incidents will happen in other countries, in other cities later on. So as the more knowledge we have and the more shared information we have, the better it is. So this leads to the conclusion that any best practice experienced in this area should be shared and made available to the public in order to increase common knowledge. I've also experienced during my years following this subject that the different fire brigades and fire officers have a different knowledge and different attitude towards the relative fire risk of BEVs. Some are brilliant, while others are more into prejudice. So, but even so, we feel from the experience in the aftermath of this fire that it actually may have helped to change consensus concerning the BEV fire probability. A very unfortunate happening, but luckily no lives were lost, no people were hurt, and it's only a matter of economical losses and of course a lot of smoke. So this rounds off my presentation. If you have any questions regarding the Norwegian situation, please come forward.
Thank you, Ståle. Really interesting. Really appreciate your contribution on this. I think there's a lot of lessons learned on this topic. So I did get a very simple question on this matter from the audience. So an increased risk of fire in battery electric vehicles is actually fake news. Ståle, are you still there? I think he left.
Pushed the wrong button.
He pushed the wrong button, I'm afraid. So,
but to answer out of the perspective in Holland, this question, there's a lot of fake news, and of course this is due to the television programs we had in Holland, for instance, where somebody who is claimed to be a specialist tells us that we're all going to die if we are going to park our electrical cars in parking garages. That doesn't help, and it's a lot of. I have a lot of respect for the Norwegian colleagues who try to fight against this fake news, because that's very, very difficult. And actually, I can only say that we experience the same in sense of that the fire brigades are having a lack of knowledge. In Holland they see a lithium-ion battery as a lithium-ion battery, but they make no difference for a lithium-ion battery in a car instead of in a laptop or in a mobile phone or in an electrical bike. And there is a lot of difference because of the battery management systems and onboard chargers.
Yeah, I must admit that I also invited a speaker from the Swiss organization, like the Swiss federal government. Actually, they have done a study on the risk minimization of electric vehicles in underground traffic infrastructure. Also in Switzerland as well as in Norway, they have a lot of tunnels. And they also started to question, if the fire should be happening in a tunnel, what will be the cause of this? So the Swiss have developed a really big study on that, and also there is indeed a change of fire hazards due to electric vehicles. They have done a hypothesis and also projected objectives. They have done test material to test space and locations. They have done also checked out what the result was from the fire water that I have used. And I will certainly share this study, which is now also published in English with our audience that was present today.
It's in our list as well.
Yeah,
which I mentioned.
And definitely, this study has a really positive come out. There is actually very little negative impacts that we can discover on the fire of electric vehicle in a closed area, as parking lots, as tunnels, etc. So
the problem only is that the media will not mention this kind of reports because it's not breaking news that there is a study that the breaking news they brought before that all cars are dangerous isn't true. That's the problem we have to face.
Also, there is so many fires on a classical internal combustion engine daily, percentage-wise. We don't bring this in the news anymore. It's much more exciting when a Tesla catch fire.
Yeah,
I mentioned the name, so sorry for that. But okay, thank you. We shared quite some good insights from today. We will certainly share the presentations. I will also share the study of the Swiss government, which was really contributing on this topic. Unfortunately, they could not join today. Looking forward to our next webinars to join you. We're looking there also to the development of the new battery technologies, and also at the end of the year, we are looking what the global impact was on the EV market during these exciting COVID years. Thank you very much. It was good to have you here today on a new platform. Hope it went well. Also looking forward to have your feedback on this part. Have a nice end of the day. Thank you. Bye-bye.